I think either didn't get or you did get. But once you understood it, it is pretty straightforward. So if you think back to the lesson before that, we learnt about what we call the nth term rule. Okay, so the nth term rule, okay, looks like this. This is for arithmetic. What does arithmetic mean, guys? Plus and minus, same amount. Okay, so nth term rule for arithmetic. Does anyone remember it? What's the arithmetic nth term? Yep, so it's going to be Tn equals, write it like this. Yep. A plus n minus 1 minus d times d. Good. Okay, so that's our nth term rule. Now, maybe I didn't explain it before, but the nth term rule, okay, you can write here, it's used to find any term. Okay, used to find any term. Okay, if you're looking for like the 50th term, the 100th term, the 1,000,000th term, then we use the nth term rule for it. Okay, it's the rule that basically gives us any term that we want. And just remember, what does A and D represent? A represents your first term, the first number, different to the starting number, okay? And D represents the common difference, so how much it goes up and down by each time. Okay, that's the nth term rule for an arithmetic. Now, what we learnt about last week is what we call the recurrence relation. Okay, a recurrence relation. So I'll write that down here. It might be worth writing this again if you missed it or you skipped it. So this is a recurrence relation. Recurrence relation. And this is for an arithmetic. For arithmetic. So this is for an arithmetic sequence. Now, the recurrence relation looks like this. So it's got T1 equals A. And what that's saying is basically the first term. What's the first term in my sequence? So you have to tell me what is the first term. And then you have to put a comma and then tell me how do you get the next term. That's what this means. Tn plus 1. Okay, term, next term is equal to Tn, so whatever term you have, and then plus the common difference. So this is what you look for in a recurrence relation. It's basically a set of instructions, and the idea behind the recurrence relation, so this is the difference between both of them. Arithmetic, nth term, used to find any term, but a recurrence relation is used to generate a sequence. So what that means is if you want to make the first 5 numbers in a sequence, this is what you use. It's used to generate a sequence. Okay, does that make sense? Generate means just to list down the next 5 numbers. Whereas for an nth term, it might ask you, what is the 100th number? Okay, so there's a slight difference there, but they're both similar, okay, because they both have very similar information. Remember, the nth term has the first term and the common difference, but the recurrence relation also has it. It's got the first term and the common difference there. They have the same information. It's just laid out in a different way. One is used for figuring out a really, really high number, and then the other one is used for just generating like the first 5 numbers, for example. That's when you use a recurrence relation. Okay? And that's what they look like for both arithmetic sequences. For geometric, which is when you're multiplying, like we'll come to that later on, it's a little bit different, okay, but similar principle. So that's what we learnt about last lesson. So here is an example of your recurrence relation, or the format of what the recurrence relation looks like, right here. So you've always got the first term and the common difference. And it's used, again, to generate, okay, to just create the next set of numbers. Whereas the nth term, okay, so this guy, the nth term, also has the same info, but it's used to actually find any term that we want, okay? So again, used to find any term, the nth term rule. All right, so let's move on. Here you get a question where it says, here's your recurrence relation, generate the first 5 numbers. Okay, so remember your recurrence relation used to generate the first five any term. So here I can see that I've already done it here, but you want the first five numbers. So I can see I put it on my table of values. Here are the first five numbers: 1, 2, 3, 4, 5. First number is 24. Just verify that that's the case. Yep, it's 24. And it says here in my recurrence relation to get the next number, you have to minus by 2. So that means term 2, okay, T2 would be whatever T1 is minus 2. I remember Joseph mentioned before he did this. So he went T2 is equal to T1 minus the common difference, which is T2 to be T1, which is a value of 24. Let's fix that. 24. Take away the common difference of 2. So that means T2 equals 22. And that's what we have here. Okay, T3, if you wanted to work that out, would be T3 is equal to T2 minus D. So T3 would be 22, take away 2. That means T3 is 20. Okay, and that's what we did. And then graphing that is pretty straightforward. I think most people understood the graphing side of it. Just make sure you put N on the x-axis, and then you put Tn on the y-axis. Okay. Okay, now this is, yep, and then as you can see here, part B is when you use the nth term rule to find any high number term. Remember the nth term rule, you use to find any term that you want. So I use this as my nth term rule. So you have A as 24, so the first term is 24, and D was negative 2. And you're looking for the 33rd number, so that's what you change for N. Okay, and we got negative 40 for it. Okay, I might do this one again, because this is what we got up to. Now this is where, I don't know why people got confused now. Instead of using T, I just used P, and then everyone started freaking out. It's the same exact thing, okay? It's just sometimes the letter doesn't make a big difference, okay? It just depends on the variables you're working with. So if you look here, we're looking at these shapes, okay? And it's each side of the shape is equal to 1. So each side of these squares is just equal to 1. And we're measuring the perimeter of each snake or each shape, okay? And it can be found by counting the sides of the blocks around the shape itself. The perimeter of each new snake built is 6 units longer than the previous. Okay, good. That's fine. That makes sense. Let Pn be the perimeter of the snake shape N. So what this is saying is, instead of using Tn, we're just going to use Pn. Okay, that's all it's saying. That's what this part is saying. Okay, that bit. So we're just going to use P. Here is a recurrence relation that models this situation. So part 1, what does P1 equals 10 tell us? Part 2, what does the rule tell us? Okay, so I'm going to answer that here. So let's go in this. And I notice, I'm sorry, I should have used the space that I provided here for you guys. So let's answer this here. So if you look at the recurrence relation, guys, it was this. P1 equals 10. And then Pn plus 1 is equal to Pn plus 6. So if you look at P1 equals 10, what does that mean? It's the first term, good. P1 equals 10 is the first term. That's all it is. It just means that's the first number in the sequence. Okay, part 2, what does the rule tell us? So this rule here, Pn plus 1 equals Pn plus 6. What does that mean? What does that mean? What does it mean, this bit here? What is that saying? To get the next term, what are you doing? You add how much? 6, that's it. So that means for the rule, Pn plus 1 equals Pn plus 6 is saying, okay, actually I might write to get the next term we add 6. To get the next term, we add 6. Okay, shh, that's all it's saying. Okay, so the next part is we use the recurrence relation to generate the perimeter for the first 4 snakes. Okay, and then we have to construct a table for it. Okay, which is basically the same as what we did here. So make the first 4 numbers, okay, and then generate the graph for it. So in order to do that, I want to find, okay, so you make a table of values like this. Okay, so we make a table of values, and instead of Tn, we're just going to use Pn. Okay, so instead of Pn, we use Tn. So n is the number, Pn is the value. So n goes on top, Pn on the bottom for this. And we only need the first 4. So 1, 2, 3, and 4. Now, I'm going to actually use the way that Joseph did his working out, because in year 11 and in year 12, this is actually how they want you to show the working out. As annoying and as tedious it might be, because you can just look at it and say, look, so it starts at 10, and I'm just going to add 6 each time. Like logically, you just need to go 10, 16, 22, 28, 34. Done. But they want you to show your working out for this. Okay, so I already know this is how we do it. P1, we know is going to be 10. That's easy. Okay, so we write 10. P2, what's P2 going to be? Well, P2, remember the recurrence relation says Pn plus 1 equals Pn plus 6. So that's going to be P2 will be equal to P1 plus 6, or plus the common difference, sorry. Okay, that means P2 will be equal to 10 plus the common difference of 6. P2 must equal 16. So that means second value, 16. P3, okay, similar thing. It's going to be P2 plus the difference. So P3 is equal to 16 plus 6. Therefore, P3 is equal to 22. So that's our third value. And our fourth value, P4, is equal to P3 plus D. So P4 must be 22 plus 6. Therefore, P4 is equal to 28. So we put 28 there. Okay, there's my table of values. Nice and easy. And now we do our graph for it. So the graph, remember what your axes are. Down here on the bottom, you have the number. And here you have the value Pn. Okay, and you only want the first 4. So we want 1, 2, 3, 4. And looking at my graph, I can see it starts at 10 and it goes up to 28. So I might just go up by 5s. I might just put a little break here, so I know that I've skipped some numbers. And I'll start at 10. So 10, 15, 20, 25, 30. You can use other values as well. I think some people actually go up by 6s. That's also fine. Okay, so the first value, P1, is 10. So that's the first dot right there. Second value, 16. So 16 should be just above 15. Third value, 22. So that's about over here. A bit more than 21. And then fourth value is 28. So just under 30. Once you've done that, join the dots. You can just start from there. Oops. Join the dots like that. And there's my graph. Okay. Makes sense, guys? It's really easy. Okay. So just keep in mind, right, that the recurrence relation is used, so this guy here, to generate your terms, whereas the nth term rule, so for example this rule here, is used to find any term. If I asked you, there's more to this, sorry. Okay. I've plotted my graph. So really quickly, guys, how can you describe this graph? What are the 3 elements about it that we can talk about? So it's a strong, positive linear graph. Right, pretty straightforward. It's strong, it's positive, it's linear. Shh. Alright, part D, last bit. So this is now where we use the nth term rule. But remember, think back to the recurrence relation. It's like this. The recurrence relation was P1 equals 10. So the first term was 10. And then to get the next term, Pn plus 1, it was Pn plus 6. So can anyone tell me, in this rule, how do I change this, or how can I use this now to find my nth term rule? Okay, my nth term rule. Remember what the nth term rule looked like? Was this Tn equals A plus n minus 1 times D. But instead of using Tn, let's just use Pn. Okay, it's the same thing. I'm just using P this time instead of T. Yes. Good. So Bella's saying you have the A and the D in there already. Can you tell me which one is A and which one's D? Good. So in my formula, all you're changing is A and D. So it's going to be Pn equals 10 plus n minus 1 times the common difference of 6. And which term are we looking for, boys? In this question, which term are we looking for? Read the question. 50th term. So I'm looking for the 50th number using my... Yeah, where n is. So you're just going to change it to 50 now. Oh, equals, sorry. 10 plus 50, take away 1, times 6. So you put that in your calculator. I'm going to trust you on that. 304. And that's it. That's basically all that the questions will expect you to do. So if you're able to do this, and every single other part here as well. So creating the table of values, using that, and showing the working out like this, which is what they would want in a SAC, then you're good. Alright, so if you haven't already, I'd like you to do exercise 8D, but from the checklist. Okay, so if you look at the front of your booklet, 8D says all. All of 8D. Okay, if you've finished 8D, I'm happy for you to go ahead and do E and F if you like. Okay, but 8D is what we're up to. I'm going to come around and just check where you're all at with it. I'm thinking 8. Let me just stop this.